here is the contents for this morning. And the first we will have a brief introduction of iDesktop, and then we will do some exercise about how to make a 2D map, or how to do 2D spatial analysis, and then at last we will demonstrate you how to use our 3D. And first, here I share the software download link, and this for morning we need to prepare iDesktop and iDesktop training references and data. So this is these two links we need to prepare before we begin our training, and this is for afternoon. So after you download iDesktop, I wish you already installed the iDesktop following these steps. First, if you already downloaded iDesktop, you need to unzip it and double click setup here, setup to install it. Following these steps until the end. And if there will be a new iDesktop icon on your PC's desktop if you successfully install it. So here we begin our training. First, I will briefly introduce the iDesktop products for you. So about the iDesktop, there are three contents we are going to talk about. The first is about the technology system of SuperMap GIS 10i and the product family of SuperMap 10i. And the last is the iDesktop introduction. So here is the SuperMap GIS 10i technology system, which you had seen this. You have seen this yesterday. This is BITCC, means Big Data, AIGs, and the new 3DGs and cloud native cross-platform, which all our 10i product family are based on the BITCC technology, and this is all the products of our SuperMap. And here we see the iDesktop is one of the terminal GIS for PC, and there are two types of iDesktops. The first one is iDesktop Java, or we call it iDesktop X in 10 version. This is a cross-platform product, and the next one is iDesktop.net, which we usually use in our Windows operation system. So for today's training, we will use iDesktop.net. So the iDesktop.net is based on SuperMap and Objects.net, and with the object.net and core library iDesktop.net can realize data conversion, data processing, or spatial analysis, network analysis, such as all these functions. Also, the 3D spatial analysis, all these functions based on the SDX plus spatial data engine, such as the UDB, UDBX, and the server, Oracle. So we want to know what exactly the iDesktop GIS platform do. Here we list 4 main aspects. The first one is that iDesktop can be a spatial data production tool, and the second one, iDesktop can be a data mining tool, a platform, and the third one is that iDesktop can be a 2D and 3D integrated GIS application platform. And the last one, iDesktop also can be a desktop GIS development platform. Now let's see each of the functions in details. So as a tool for producing spatial data, the desktop GIS platform can provide the ability to input, store, process, query, analyze, and make maps for spatial data through a friendly visual interface, such as the important one is the spatial data acquisition and processing, such like this picture shows. We can convert the files such as Excel or CSV files to the spatial data with point or line or region, and then we use this spatial data to make a beautiful map. iDesktop also provides spatial data management, which there are varieties of types, such as you can based on SuperMap formats with UDB or UDD or UDBX. Also, here we support Chinese databases such as BeyondDB and the open source databases. DB2, MySQL, PostgreSQL are all supported in our iDesktop. And iDesktop also can be a tool to journalize the spatial information representation, such that you can make a rainfall map or public electric map or grid map, such like this picture shows. And iDesktop also can journalize thematic information analysis, such like the SuperMap generated with discrete points value interpolation, or the location and location analysis result map. iDesktop also can be a data mining platform which can produce statistic charts to represent data in a vivid graphic way, which helps discover the trend distribution and the relationship of data. And as a 2D and 3D integrated GIS application platform, the desktop GIS platform can realize the spatial representation and analysis of businesses and 3D presentation and analysis. Here are some examples about the 3D scene and the 3D analysis. Also, iDesktop can be a GIS development platform. it enables you to customize the interface, develop your own business modules based on the existing desktop GIS platform, to quickly customize your own desktop GIS application platform. Such like this, you can customize this splash screen and also develop your own desktop with your own logo and your customized functions and the title. So that's all for the introduction of iDesktop. The next, first we are going to getting started with SuperMap iDesktop. This part we will talk about how to get SuperMap iDesktop products, and we will talk about the trial lessons of iDesktop and the interface of iDesktop, and last we are going to talk about the GIS data organization. The first, we can get the iDesktop products via our official website. And there are two types of iDesktop. One is full package, just like I send just like this training we will use. The full package is needed to. The full package needs to be installed before we use it, and we can also choose the green package, such like this web Win64 bin. This is green package, which we can use it just unzip the package. We need to install it. The differences between these two packages is that the full package provides help documents and some sample data, so you can quickly getting started with our iDesktop. So this training will use the full package. And then we need to know the trial lessons of our SuperMap. SuperMap provides 3 months trial lessons. How to get the trial lessons? If you use the full package of iDesktop, you will automatically activate the after you installed it. And if you use the green package of iDesktop at the first time, you need to run this license center under this root to install the trial of the license center. And then if your license are expired, so you can also send your computer name or report file to our email to update the license. Here is this picture shows that is the license center. Here we can see if you have 0 official license and you have activated 1 trial license, remaining time only 54 days. So this is about the trial license. And then after we installed the iDesktop and got the trial license, we can use our iDesktop. This is the main interface of iDesktop. Here we can see this the top of the interface is quick access bar. Here we can just open our iDesktop. If you download it, here will be icons for you to you can double click it to open the iDesktop. So I already opened it. So here we can see the top of the interface is the quickly access bar, which the commonly used features are organized here, such like pan, or zoom in or zoom out, or full screen, or such as under the quickly access bar. This part is the ribbon which organized all the functions of iDesktop. Here is their start menu, data, 3D data, and analysis. All these functions are under the ribbon. And then at the middle of the interface is the window, which you can use this is used to display the maps, such as Agile code. So if you just open the iDesktop, here is the start temp. Here we can see you can learn the feature of the iDesktop and open data with the workspace. Also, there is online maps and the sample map. So we can just go open the sample map. Then here we can see this at the middle of the interface, we can show the map. Also, if you open this thing or diagrams or layout is all showed displayed at the window. And at the left of the interface, there is the workspace manager, which manages all the data and maps and layouts. And under the workspace manager in layer manager, all these layers composed are the whole complete map. And here we can see under the window there is a status bar. It's used to display the scales of the map, or the center point of the map, and the projection of the map. And at the bottom of the interface, there are output window and task management. The output window will display the information generated during operations, and the task management will show the progress of your operations. So this is the main interface of the iDesktop. Then let's go back to our PowerPoint. The next, we need to know how iDesktop organize GIS data. In iDesktop, all the data are managed in a workspace, and the data in iDesktop a series of data sets, which the data sets stored in Datasource, and all the maps, layers, things, resources are saved in a workspace, such like the picture shows at the bottom of the at the top of the this is a workspace manager, and the word is the workspace name, and under it is data sources, which manages all the data data source. Here we are word, and in the data source, it organized all the data sets, the text data sets, region data sets, 9 data sets, and the maps, things, layouts. You may wonder what is a workspace. The workspace is used to save the work environment, including the open data sources, save the maps, layouts, resources, and 3D things. At any time you start the application programs, an empty workspace is created for you to enter data, or you can open an existing workspace. And according to how workspaces are stored, there are two types of files, the file workspace and the database workspace. The file database, there are two formats. The first one is SXW. This is the XML file, and the another one is SMW. This is a binary format, and also the workspace can be stored in a database such as SQL Server, Oracle. And then the next is about the data source. Data source is composed of multi types of data sets, and it is the physical storage for the spatial data. And there are also two ways to store data source file type, just like the SuperMap formats, UDB, UDD, and UDBX. Another way you can store the data source in database such as Circle, Oracle, MySQL. And the data sets. The dataset is a collection of data of the same type, just like the point is a collection of data, and the 9 region dataset. All the datasets are stored in the data source or database. Layers, we can understand layer is a display media of a data set. You can display the objects in a data set with appropriate styles in the map window, and a map may consist of one or more layers. And the maps, a map is composed of one or multiple 2D datasets with specified display style. This is the steps to get the map. First, we need a series of datasets, and then we end to the layer management to set the style of each layers, and we will get a map. The layout is composed of one or multiple configured maps, as well as some auxiliary mapping elements such as the map name, changing the map scale, such as like this. Layout is physically stored in a file or database via the workspace. Then the next is resources. Resources are collections of symbol libraries used in the maps and scenes, including the marker symbol library, line symbol library, and fill symbol library. The last one is the 3D scenes. 3D scene enables the loading of 2D and 3D point, line, region, text, image, grid, model, data, and so on. So 3D scenes recognize the 2D and 3D integrated display and management. These things also saved saved in our workspace. So here let's to see each of the this elements. The first is the workspace. Here we can see if we open a workspace. Here shows the name of workspace and the data sources. It manages the channel is a data source which contains all these data sets, and the data sets then like this is 9 data sets, region data sets, and points data sets. So the data sets, and here is the maps, and under the maps there are 3 maps here. The first one is channel, and here we can see there is also channel dark. We can double click it and see the map. While you double click, open the maps, the layer manager also can change to the current map. The layers will be changed to as the current management map. And here, if you save the layout, it will be under this layouts. And if you save the scenes, it will be stored under the scene. And here is the resources of marker symbol library, nice symbol library. We can open it to see, just like this. Here we can see the marker symbol are all managed under the marker symbol library, and the fill symbol like this. So this is all about how to. The next is the layer manager. Here we can see we all can find the layers in the under the layer manager. We all can find it to at the data sets. Just like here, the river, this layer, the river layer, it is we can find it at the data source here, the river are. And the last here shows the channel. This is the data source name and data sets name with data source name. So we know the how to get. Here we already know how to get SuperMap iDesktop and the trial license, and how iDesktop organize the GIS data. Then the next we are going to do some exercise. The first we are going to learn how to import and export data. So. In this part, we will first introduce the GIS data sources where we can get the GIS data, and then we will do some exercise how to import data of other formats, and last we will export SuperMap data to other formats. The first is how we get the GIS data source. We all know the data is the lifeblood of GIS, and the acquisition of GIS data is the primary task for the construction of our GIS system. So, and it's also one of the issues with most cost of human and financial resources. So we can get the GIS data sources from the map data or remote sensing image data or field surveying data or digital data and text reports. Here we can also how to get the data. First, we can download the data from the internet or purchase from data vendors or connect or purchase from government departments or just from the field surveying. And you can get the data while the processing, just like if you have a paper map, you can scan it and vectorize the paper map to get the vector data. And also, if you have electronic data, you also can process and extract the data you want. The next, we are going to learn how to import data of other formats. SuperMap supports many types of data, include vector data, raster data, or some 3D models. The vector data such as city, or general formats DXF, DWG, or just general formats such as S-shape and the tabular data CSV is supported. With the vector data, we can only import it, but the raster data, such as the general image format TIFF or JPG, we can open it by import it or directly open it. So let's do an exercise about how to import an image data. Let's go to, first we need to close. Here with right click at the workspace, we can close workspace. Here we don't want to save it, so here we say no. And then if we want to import or open our data, we need to here we can click the data source, right click it, and here we can see you can just open data source or new file data source. Here we just open file data source. To export data, and here we find the JPG, and here is the JPG image data. Open it, and it will be like this. And this one, we can double click to open. So here with the raster data, we can just directly open it, but we cannot do any operation with it. If we want to do any operation with this raster data, such that we can open the TIFF. Here we see build pyramids. If you just open it and you can only display the data in our iDesktop. You cannot operate it. So, so here we open the import the image data, and then we can see the supported formats of iDesktop. Here are all the formats iDesktop support. Then we are going to import a CD data type. So here we are going, we just, oh, no. We close. Here, if we want to go import other vector data, we need to first build a new file data source. Here, the name, and here we can see you can select UDB-X or UDB. And then the test will be the test data source will be displayed under the data sources. Here we have two ways to import the CAD data. The first way is right-click at the test data source and import data set. Here we choose import data set, and then we end file. Here we select CD plan. Then here we can see the result setting, target data sources. Their default one is test, and the data set name you can change or not. And here the type we will pay attention to the type. For CD data, you can import it as a CD data type, or you can select the simple data set. Here we will demonstrate the differences of these two types. The first, we first select the CD type, and then we leave all this at default, then import. So here we can see the CD, data are imported as a CAD data set. So we can double click to open it, and it will show like this. All the 9 or point or test are in one data set. And then we're going to try another way to import CD. Here at the start menu, here import data. Here we can see the vector data we supported and the chart format 3D raster. Here we can auto CD. We can use this way to it is the same. If we select this, we also open this one, and the interface will be like this. It is the same as the first way, and here we change the CAD to a simple data set and import. So here we can see if we choose import as a simple data set, the data will be divided into 4 types: point data set, line data set, region data set, and test data set. We end it to a new map. So here we can see if we can control just like this, control the point 9. So we can control the 9 point the test, and this is the difference between these two types, and only if you imported as a simple data set, it can be operated in our iDesktop. Now, let's go back our PowerPoint to see the difference of these two types. For if you are CD data set, the results will be 0.9 region tests are stored together, and the original CD style are imported, but it isn't supported to do any spatial analysis. But if you imported it as simple data set, each type of the data sets are stored separately, but the original CD style is not imported, but it is supposed to do spatial analysis. Here is the comparison of two types. And then we also can be import other formats such like the shape or MIF data, it is the same way to import this. You just select your data to here and just import it, set the parameters and import it. Here we will do an exercise about how to import a shape file. Here we also under the this data source. Here we right click and find the X shape. We click the shape, open, and we leave all this default. Here the data is imported to our iDesktop, so you can do some operations of it. Then we are going to demonstrate to you how to import the attribute files. Here we have to, we will demonstrate you the two ways to import the we will import the CSV data also as well as its spatial data, or we will import this one upon its building code. Oh, sorry, not this one, this one. If you import this CSV data, the first you can just import it as table, or you can convert it to a point data set by import the spatial data with the longitude and latitude. So we go back to our iDesktop. Here we also under this test data source import dataset. Here we find the Excel. Here are two Excels. The first one is without coordinates. The another one is with coordinates. So first we import the one without coordinates. Here we need to check this first row as field information, and here we also can select or check this import spatial data. But for this one, there is no coordinate information, so we just uncheck it and import. So the result of this one is temporary. We can only see its attributions. And the next, we import the building width coordinate. Here we also check this first row as a field infer, and here we can see there are x, y attributions of it. So here we can check the import spatial data and longitude receipt x and latitude receipt y. Altitude of the value you also can select it. You can set it, but there we don't have it, so we leave it as default. So here we just import, and the result of this way, here we can see it imported as a data set, as a point data set, but we can the data set to the map. It can show the positions of the data, and we also can check the attribute table. So this is about the two-way to import the difference of the spatial data or uncheck the spatial data. Here we also can append the corner by the same field to join the two data sets. So here, this we can show. Let's have a demonstration. Here we can open these two tabs. Close it. Here is building code. If we want, so here, if we want add the building code to the another data set, or we can based on the building name. So here we can see they all have the same building name to organize it. So here we find the data, and under the data processing, here we can say append the column. Here the target data, we can select. We want to add the code of the building to the building coordinates by the join field, and here we select the building code sheet, the table, and the append field we select building code. Okay. Here is, we close it, and the result will show at under the task management. We just close it and we open it again. So here we can see the building code and is added to the point data set. So then we can show the code by create a thematic neighbor map. We can select the building code. It would be like this. So then we continue. The next, the raster data also can be imported into our data source. at the before. Okay. On the next, we are going to import the raster dataset. We also import M file, and we find the TIFF file, the TIFF. And here we can see the raster data as image or grid. Here we keep the image, and we still all this default. And here the raster data are imported to our data source like this. We also can open it. So this is about how to import the data of other formats. If you have another format, you also can try to import your data to our iDesktop. And the last one, we are going to talk about how to export SuperMap data to other formats. There we are doing an exercise to export vector datasets into shape format or export a raster dataset into shape format. So we go back to the iDesktop. Here we can try to we can try to export the 9. Here we have two. Also, we can export dataset, and here we can select the export type. We can see all the types we supported to. Here we also, if you want to export to as a shape file, here we select ArcGIS shape file. And this export path, we leave at default and export. Okay, I think so. Here is the result of the export data. So the same as the raster data, you also can export data set. To select the export type you want to export and see the export path to export the data. So let's go back to our PowerPoint. That's all for the how to import and export the data. The next we are going to make a professional quality map. We firstly briefly introduce this introduce how to make a professional quality map, and then we will have a break for a while. So here we first introduce how to make a professional quality map. If you want to make a 2D map like this, here we the 2D map are composed by general layers and thematic layers. And the steps to realize map making is first we need to add data to the map window, and then add the data to the layer manager, and then adjust the order of the layer. The most important one is see the general layer style and create a thematic map layer. And after we see the layers, see the styles for each layer, we can also optimize our 2D map by fixing the map skills or mapping for skills. At last, we need to save the map in workspace. So iDesktop supports the semantic map of unique values map, ranges map, label metric map, graph map, such like this. And also supports the raster semantic map, such as the grid unique values map and the ranges map. We are going to talk about how to set the layer style. The first one is how to set the general layer style. There are two methods. The first one is click on the markers under the mark symbol or line symbol under style settings menu and select a proper symbol for the layer. And the method 2 when is just to select the layer and right click it. Then here we choose this layer style. And there are also two methods to create semantic map layer. First, it is also under the menu of semantic mapping. Here we can select the semantic map you want, and the second method is to select the layer and right click. You can see a correct semantic map here. We can choose the semantic map you want to create. And after you choose the semantic map, there will be some parameters need to be set. And the properties, the expression or method, and here you can change the styles of each part or the range. And then after we have after the style setting, we also need to fix map skills to optimize our map to make it much more beautiful. And also we need to set the mapping for skills for each layer. We can set the skills to each layer with the max visible skill or min visible skill. The max visible skill is that if the current map skill is greater than the given value, and the layer will not be visible. And if it is the mean variable scale, if the current map scale smaller than the given value, the layer will not be visible. So the last tool is to save the map and the workspace. Here we are going to we demonstrate you how to journalize all this, to create a 2D map. Here we just close the workspace before we select no, we don't want to save it. And then here we find we open our workspace, open file workspace. Making provision. Here we can see this is the data we will use. Here we firstly look at the results of the map. Here we can see the map is with the text. The text layer. We can, if we zoom in, we will see much more information. If we zoom out, the road will be invisible. So we're going to create a map just like this. Here we add this state R, and we only add the main cities and the interstate map. We select this three data sets to add to a new map. So if you just add the data set to the map, it will with a default style, but it is not beautiful. So we are going to make it much more beautiful. First, just like we are going to set the line style first. We right click at the line symbol and the layer style. For this is road line. Here we can select the default one, or another transportation. Here is some default road. We can select. Road, or we can select basically line. We can select first class, second class. We can select the road just like this. Is the maybe the first class. Select this one and apply it, and it will be like this. Or we can change it. Then the road will display like this. We just invisible the other layer. And then we are going to set the state layer. Here we are going to set a thematic map for it. So we are going to set we are going to create the thematic map and select the uniform value map. Here we can see this is the default expression with ID. So there are so many. It's divided into these labels, and also we can change. We can put expression just like we are going to. We are going to display the population. We are going to see the thematic map by the population of each area. So here we can express. We can select pop and divide the arrow and 100. Okay. And here we select we can select a color scale. Or we can change the unique map, a range map. This. So it will be like this, and then we want to show the state name. So here we also create a thematic map. Here we select the label map, uniform. Okay, and here we can see the state name I showed at the map, but we need to change its style. Here we see the styles. Maybe we can change the font, we just leave as default, or we can change the color. We select one color. Oh. We select one. And just we select this one, and but the map is still not beautiful because in this level we don't want to see the road, so we are going to change the scale of the map, of each map, of each layer. So how about we have a break, and we have break for 10 minutes, and then we'll go back to optimize this map. Welcome back. So let's continue to optimize our 2D map. We already set the state as a thematic map, and we set the road, and also we add the road state name. So the next we are going to optimize this map. So I think this color, this print color may be not too proper for this map, because we don't have we can't select a proper color to fit all these range. So here we also can change another range. How about we change it to, also we select ranges map. We select this one to have a try. Okay, so it will be like this, much better. And then we are going to change the state names. We set the color. Maybe that's much better. And then we are going to change the road color. Here, their style. Maybe this one. Maybe this one. Okay. Then also here we end the main city. The main cities set the main cities style. Here we just layer style,
And we can select one here, settings, basic symbol, marker city, can select one. This one. We select maybe this one. It's too big. Yeah, maybe this one. And it will be shown like this. And then we end the main city's name by create thematic neighbor map. Here, the properties with the city name and the styles. We change the font. We change it as arrow, and we also can see it. We can bold to see it. Okay, it looks like this. And then we are going to change the scale of the map. First, we right-click at the main window and we select the properties. Here we can see the set scale, and here we can end scale. Then like this, we can end this 3. Maybe we just set this as default, or we can change it. We say it's 1 million and 700,000, and here this one we set 3. Yeah. 700,000. So we just okay. And here we can see here we come to zoom out again because the skills we only set these 3 skills, so we maybe need and another. Maybe add 500 or 5 million. 1, 2, 3, 4, 5. Okay. It's also too small. $2 billion. Then here we can zoom out again, so we can set a property skills for the map and or for the whole map, and we also can set a skill for each layer. So just like this, we don't want to display the road at this level. So here we can just zoom in, and we right click at the road layer, and here we set the visible scale, we set the current scale as mean scale, or we can set this current scale as max scale. So here we just as mean scale. Let's see what will happen. So here we set it as mean scale at this scale. So it would not be displayed at the scale smaller than it. We only zoom in, it will be displayed. So this is each layer can be set its visible scale as a mean scale or max scale. You can have a try to set a property scale for each layer. So I think this is how to make a 2D map with by setting the general layer or creating the thematic layer. Then let's go back to our PowerPoint. So this part we already know how to make a 2D map. And the next we are going to have some spatial analysis with iDesktop. Here I already said the fourth part is buffer and analysis. The fifth part are queries. Here we change the order of this. We first learn the queries in SuperMap. So we open it. Here are three ways to query using iDesktop. The first is simple query, and the second one is spatial query, and the third one is circle query. Let's see the details of each query. The simple query is to build a linkage between spatial data and attribute data. It can be dynamically showed the spatial the objects and the attributes. Also, we can check the detailed properties of each element. Just we can see its properties and also its spatial information and its nodes information. So here we are going to show a simple query. So here we'll open. The next about this thematic map. After we creating it, we should save. We should save the map we made. Also, we can rename it, and or save it as default name. Then we need to we need to save the workspace. So if we save it, here we can see the map we created will be under the maps menu. If we open it, it will be the map we made, and keep all these styles. So here we just close workspace, and then we're going to open a new queries data, and query we end this using the two query and word these two database or data source. Here word, just like we end the word to new map. The simple query is about is by this way. We right click at the layer of at the layer you want to query and browse associated table. Here we can see the first one, just like the attribute highlight, and also the corresponding element is highlighting it highlights at the map. We also can locate by the attribute by selecting the attribute table. We also can select the elements at the map on the map, and also it will show the it will highlight in the attribute table such like channel. Here will be highlight the channel, and here we also can right click at the selected element. We can see its properties. Here is the properties of the selected element. You can see its fields and the values, and also the spatial information and the load. If we select the load, it can locate the point of the load location. So this is the simple query, and let's go back to our PowerPoint, and the next is spatial query, and this spatial query is used to compose filter expression according to the spatial relationship among geometric objects, and get objects satisfying the filter condition from the existing data. And the query, the spatial query can recognize, you can use spatial query to find which countries are located on the equator, or found the house, which house should be removed if roads need to be widened. And there are various conditions among the spatial query of each, or among the data sets, just like the cross condition, contain condition, within overlap condition. So here let's have a demonstration to find the world countries located at the equator. So here we go back to our iDesktop, and then we close the attribute table. We just click at the blank area to make all these areas unselected. And then here we already add the world map, and we add the grid and to current map. So here we are going to select all the countries which are located on the equator. So here we first select the equator. If you don't know which one is the equator, so we can also create a label uniform map thematic label map. Here we can see it shows the label of each grid. Here we select the equator grid, and then we find the analysis menu and query button. Here is circle query and spatial query. We select 2D spatial query. So here we can see that the searching layer is grid, and here we can see the spatial query condition. We want to find the countries which located at the equator. So we set the query condition maybe at the intersect. And also we can see the query distance, and we also can save the results. Or we can show the results brought in attribute table or highlighting map. If you are 3D seeing, it will be highlighted in scene. So here we don't, we save results and query. So here we can see all the countries at the equator are highlighted. We also can and the attribute table also the corresponding elements. And here is the new result of the query. So we can, and so this is the spatial query result. This is about spatial query. Now let's go back to our PowerPoint. We also can use spatial query to find the rivers in our country. The first we need the steps to find all rivers in one country. The first step is query which rivers intersect with China. And the step 2 is to get those rivers in China by overlay analysis, and to sum the length of Chinese river by statistical function. So here we just select all the rivers in China. We close the attribute table. We close this. We don't save it. Also, we set the grid invisible, and we end the rivers under the work data source. We end to current map. So here are all the rivers. We can change its style to make it much easier identified. Okay, just like this. So we want to select query the rivers in China. First, when we just select China. We click the China and then analysis, spatial analysis. Here we check rivers layer and set it intersect to region line. And here we can save the results or not. And we can rename it. Highlight, okay, we can query. So or maybe this is not this color is not obviously, but here we can see all the rivers in country, the attributes as here, and we can just open the results of it. It will be like this. So this is the result of spatial query of rivers. The next, we are going to talk about the circle query. The circle query is to construct a circle expression to query spatial and non-spatial data. Here we can we are going to query the countries which population is more than 100 million and store the query results in a new data set. Let's go back to our iDesktop. We close it's available. Here first we also use the word layer. And then we find the analysis circle query. Here we select the word, and here we need to set the result of the you want to output. Here we just like we want to output the country or the population, and here where the population is greater than 100 million. So also we can save the results or highlight in map or browse attribute table. Here the datasets query. Let's go back to the results. Maybe I think the parameters go some wrong. Circle query with word we select country and population of 1994, and then where the population is greater than 100 million. Map let's see the attributes of the word first. Population 1990 100, and we see attributes structure of it. We can see the double right. And let's try again. Analysis circle, word, the result. The result goes some wrong here. Expression query. Select all and just try the same user ID. We have a try. There's maybe some question problem with this brain. I think I will check it later about this SQL query. Now let's go on. If we set the this sentence, the sentence of the circle, it will choose the elements which content which meet this expression. And here is the introduction about SQL queries parameter. So about this select the query results field setting and where the query condition, or we can also sort by the result. So here is the result of SQL query. Also with SuperMap, we can query data from more than one table based on a relationship between certain fields. Just like here, we can set the associate field to select another table to get the result of the SQL query. The result attributes will combine the two tables. Such like this, we are going to we're just going to have a try the next. Here we open the query. Then this one we open this data set under the query data source. So here we are going to query. We are going to query the situation satisfied this expression is that the editable the edge from 80 to 29 greater the number of this edge are greater than 10,000. Here we also find the analysis SQL query, and then we just clear the before sentence, and we want to select the name or state name. Or here we can set associate field and the editable this table. Here we just select join. We related field. We said we use the same ID to relate these two tables, and the expression is this same ID is equal. Okay. So here we can see the table, the attributes in this table are also ended in the fields. So here we also can we can select the result the age 80 to 29 to the select parameters, and where we are going to say the age 80 to 29 greater than 10,000. So here, highlight and save results. Checking which. So here we can see the result is displayed, and all the elements which are greater the age from 80 to 29 the number are greater than 10,000 are selected. Here we also get a result data set. And here we can see the attribute table. Here only shows the fields we selected, and just like this two one is from the region data set, and the last one is from the editable table. So this is about the related query. So this is all about our query part, and the next we are going to going to demonstrate the last part of 2D analysis about buffer and overlay analysis. Here we buffer. With this part, we will going to for buffer analysis, we are going to create buffer for selections or for dataset, and create multiple ring buffer. For overlay analysis, we are going to introduce all these overlay operators, and we just only some of the operators. So what is buffer? Buffer is an extension space created around a given object, such as a point or a line or a polygon, or can be supported to create buffer. So you may want to know why we need to create buffer. In the practical application, we can create buffer for the selected road line, and then use the buffer result to create residential buildings intersect with the buffer region. And we also can find what neighborhoods will be affected by the flood, or find which area gets affected region around some dangerous spots. So we are going to create buffer by selecting 9 data sets. Let's go back to our desktop, and we close the previous workspace. No, I don't want to save it. And then we open the data source. We are going to find the buffer and overlay data. Here we select buffer analysis on data source. Here we end the road and building. We end these two data sets to new map. Here we can see this is the. Then we just select this road, and we are going to find an analysis and the buffer zone. So here we can see the data type is already selected 9, and here is already checked. The selected objects only checked. If we uncheck it, it will do the whole data set of those. So we checked this selected objects, and without setting, we can union buffer if there are more than one element. Such that if we select this, we can union buffer. And here we only have one element, so here we don't check. We don't need to check it. And the buffer type can be round or flat. And the union here, the left radius, we can see the radius of the left and right. We can see this, we can say it as same value. If we select round, it will be the left and right radius would be the same. But if we select flat, we can see the different radius of each side. Here we also can save this, it will generate a new data set. So we just, okay. So here we can see the result. Because we set the left as 5 meters and the right side as 3 meters, so these two parts are different. So the widths are different. Then we with this result we can select which buildings intersect with the road expanding. So here we select the buffer result, and then we find the special query. Here we select check the building layer, and we set the intersect region. Here we can query. So here we can see these two parts of these two buildings intersect with the expanding road. So here is about the selected buffer, and then we will demonstrate to you. We will demonstrate you to do the to do buffer with all data sets. Here we can select the. Here with the data type, we select 9, and the road. Here we will do the whole data sets, and here we set the union buffer, and flange. We can also set it as same. This time we can set the buffer type as round to see the difference with the flat. And the results would be the buffer 2, okay? So this is the result of the whole data set buffer. And we can see at the terminal of the road, this is round. And if the flat, if we set the type as flat, it will be flat. So let's go back to our PowerPoint. And this is about the buffer. We already, and we also can create multi-buffer zone for just like for railway line to analyze different levels of noise affection to the residential areas nearby. The point line and region data set are supported to create multi-buffer zone. Here we are going to do an exercise about how to create gradient effects for country boundary, and this country boundaries ID is 10, So we will use the circle query to select the boundary at first and make a uniform map for the buffer result data set. Looking at this. So here, let's go back to our oh, sorry. I think I forgot to put the training data here. I think let me check. Oh, only these two data sets. Oh, here we will only show the multiple how to create multiple buffer. So with the road, it is the same. So here we start buffer row, we select multi-buffer row, and the data set with next road. Also, we can buffer type flat or round. We can union buffer, and we can set the results, and we can end the videos. Here we can set 3 to 50, and the step we set 5. And okay. Here we create. So the result will be like this. Maybe we would better just select one road. Here we just select this one, and buffer row multi. So here it is the selected objects are only checked, and here we end the 5. So too much. Let's start by yes. Okay. So the result will be like this, and here we also can create a thematic map to set the different color. We select to the theme user ID. It will be like this. We can set, we can change the color. So this is about the multiple buffer. Then the next we are going to now about the overlay analysis of our desktop. The overlay is an operation of comparing variables between two data sets. With this function, we can use it to find out the lag distribution of a certain province, or with the non-use data in 2 years, we can get the non-use changed areas in these 2 years using semi-trace or semi-trace. or within land use data and recovering forest distribution data, or we can get the new land use data after recovering using update. So let's say SuperMap currently provides 7 overlay operators that clip, erase, intersect, union, identity, XOR, and update. Then the next we are going to introduce each operator in details. So the first is clip, and the clip is a process of extracting a set of features from a clipped data set using a clipped data set. The set of polygons in the clip data set defines the clipping region, and the features or feature parts that fall outside of these polygons are to be erased, and the ones that fall within the polygons will be output to the result data set. And the result and the attribute table of the output result of a clip operation comes from the attribute table of the clipped data set. So the result is the same with that of the clipped result. So this is a clip. And the union. Union is an operation that finds the union of two data sets. After a union operation, the polygons are split where the two region data sets intersect. Topology is reviewed, and the geometric and attribute information for the two data sets are all output to the result data set. And the next is intersect. An intersect operation finds the intersection of two data sets, and the spatial information for a result data set from an intersect operation is the same with that from a clip operation. So the result of this, spatial result, so the result data set of intersection result is the same with the clip operation, but the clip operation does not process attribute information. An interact operation allows the user to select attribute field to be reserved. It means that if there are dataset A on the dataset B want to do intersect operation, the user can select attribute fields need to be reserved from the attribute tables of dataset A and dataset B. And the next is about XOR, which we call the symmetry difference analysis. This is also on two region data sets. For each region object, the operation erases the part that overlaps with geometric objects in the other data sets, and then the result part of the object is reserved. The identity is a process of performing an intersect operation on the source dataset and the overlay dataset, and then a union operation on the intersection results and the resource dataset. Update is a process of replacing object parts in an updated dataset with corresponding parts in an update dataset, where the two datasets overlap. So it is a reasoning process followed by a parsing process. The geometric shapes and attribute information in the update dataset are reserved in the result datasets. So let's go back to our iDesktop to show some of the overlay operators. First, we close the buffer exercise. Close. Then we open the overlay analysis data source. So we end these two data sets to new map. The first one is administrative region, and another one is non-use. We reorder the data map. It will be like this. And here, we just show the clip and intersect, and see the difference between these two operators. At first, we are going to find the analysis also under the analysis menu, and overlay analysis. We click overlay analysis. Here is all the operators of overlay analysis. Here the source data. We going to select the land use. We are going to click. We want to select the land use in a village. Oh no! First, I think we need to. We're going to find. Oh, we're just going to. We browse associated table, and here, Liu Zhang. We see this village. We can select this village, and first we select this village and overlay analysis. I think we need to first output the village data as a data set. So here we can open, close it, we put it, save this this village as data set, and we select all. We don't want this. This is the default fields of SuperMap. So we only select this one, and here we set Liu Zhang from village. Liu Zhang. Okay. We set it as region, type as region. Okay. So here will be a new data set, Liu Zhang, and generate. Here we add to the current map. This part is Liu Zhang. So we want to select, or we want to only want to select the land use in Liu Zhang. Here we'll find the analysis menu and overlay analysis. We also can just click this button and click the data set with land use, and the overlay data set we set to Liu Zhang. Here is the level as default. Okay. Here is the result. We add to current map. So this one, this is about clip, and here we can see the attributes. It is the same with the land use we clipped, and then we are going to use the overlay analysis of we use the intersect, which the result will be the same with the clip operation, but here we let's say now use also the same view drum. Datasource. Intersect. Actually, the seed fields will be useful with this operator. So I think I should check it after our training. Wait a moment. Yeah, let's re-end the. I think I need to re-end the. Re-end the retrial. And the name use and user new name. Then we find the analysis, overlay analysis, intersect. Okay, that's good. Here we select name use, and then with here with the overlay dataset, we also set view drum, and here we can see the fields of the we can select the fields you want to reserve in a new data set. Just like here we select the source fields and the overlay data source. We select these two, and okay. Also, we can compare the results. Okay. Here is the result of the intersection, and let's see the attribute table. Here we can see these results are combined with the new fields of the Zhang's fields, which with the clip results cannot combine the another data sets fields. So this is the difference between the clip and the intersect. So here we also have some union with overlay analysis. You can have a try after our training. So the next we are going to briefly learn about some knowledge about 3D. The first, let's talk about the how 3D data organized and applied in our iDesktop. So here we will introduce these 6 aspects. First is the data structure of 3D model and the introduction of 3D scene and how to browse 3D scene, and the layer organization of this 3D model. And then we will see some applications. This is the data structure of our iDesktop. So here we can see the workspace is totally is a totally just like a totally file to which combined with the data source, map, layout, scene, resource diagram. So the scene is one part of the workspace. Here, which also it needs the store the data management with the UDB, UDBX or database, and the data set can be added to this thing as screen layer, general layer, or terrain layer to compose to combine a scene. So what is 3D scene? This 3D scene uses virtual-net technology to simulate various geographic features and their spatial relationships in the real world. And there are 2 view modes in 3D scene, a plane scene and a spherical scene at the top. This is plane scene, which it means the surface of the Earth is spread out into a plane to load and display features. And it supports the planar coordinate system and projected coordinate system, but it not supports to display the ocean, atmosphere, gratitude, or the gratitude level. This spherical scene simulates the surface of the Earth with a sphere. So here we can browse this 3D scene by the compass keyboard or mouse, and control the displacing elements by the mouse. Here there are 3 types of layers in the 3D scene. The first is screen layer, which is a static graphics such as logo, description with no geographic information. And the general layer is manage all the 2D data or 3D model or cache data or some or this data are managed by general layer, and the terrain layer only manages the TM grid and the terrain cache. So here this is an example to end the screen layer. It should be a watermark or logo or label, but this screen layer is with no geographic meaning. And here we can try. We can open. First, we are going to open a 3D scene. Here is some Here is some examples of the 3D scene. Just open the 3D scene of workspace, and the thing we here are these things in under the saved in this scene. Here we can just open the CVD. And here we can see all these models are managed under the general layer. Here we are going to try and a screen layer and object. Let's find the here logo. Here is the SuperMap logo. Here we can see it can't move or any operation. But if we want to operate it, we can edit it. When it's like this, we can put, or we can like this. Now, here we can see the screen layer can't move with this thing. This is about the screen layer. And the next, the general layer. General layer can support the map model, OSGB, image data, OKML file, or can support to manage it by general layer. This is different types of the 3D thing. Also, we can enter in layer. Here we are going to try and these two layers here. Dynamic terrain layer, this general layer, we can also add the OSGB cache layer. Here we compress it selects this. And then we can jump to layer. So this is the oblique geometry model. And we also can add the terrain layer. We add terrain cache layer. Here is terrain cache layer of Chongqing. We add it. We can jump to layer. Because they're the only terrain layer is not obvious to see. Here we can also add the grid layer, DEM layer. We can by this way we can also add to current thing. Here we can also add this as image. Okay. And the image will be showed under the general layer, and the DEM layer will be showed under the terrain layer. So this about this and this. And it again. Here we can see this 3D terrain will be shown as this. And let's go back to our PowerPoint. Here is we also can use this 3D flying to view our scene by the fly manager. You can have a try. Just like if this fly manager, we will first open the CVD. You can open the CVD and then fly manager, we can new a fly manager, or we will just open and will open an exist fly files. And here we can see this is the route. This is all the routes we end to this thing to realize the fly direction and route. So you can have a try just to click the fly. Here I don't show it because of maybe the web or the sorry, I don't know how to say. You can have a try after training, just open this file and click fly to see what it would be happen. And so this is about the 3D flying, and also with 3D thing we can do 3D spatial analysis such as variable analysis, channel analysis, scanline, or some all these 3D analysis. And this 3D is also supported to display on multiple terminals such as by WebGL or so on the mobile or VR and AR. So also, this is about the 3D thing, and the next we are going to briefly. I'm sorry. Sorry for
Hi all, her computer cracked a little
for
bit.
this 3D thing consumes a lot of performance of my computer, so maybe I can't continue to show you the 3D thing operations. So I wish you will have tried with my reference shared to you to see the 3D thing. What can 3D do with our using our iDesktop? If you have any questions, you can leave messages for me or any our support support center. So I think this the training for the morning will be end at now. Sorry to give you so much inconvenience. but I wish you, if you have a try with my references.